Motion of particles under gravitational force. In this lecture, we are going to explore the situations in which the particles move in circular path under gravitational force. Now, when we say the particle is moving in circular path under gravitational force, what it means? It means that is the centripetal force is provided by the gravitational force acting on the particle. Now, we have done the fundamentals in circular motion, that whenever there is a particle which is moving in a circular path, say with a velocity v, then there must be a net force acting towards the center of the circle which provides the centripetal force. Okay, and the magnitude of the centripetal force is how much? mv square by r, where r is what? The radius of the circle. This force is responsible for making the particle to move in circular path. There may or may not be a tangential force. If there is a tangential force, the motion would be non-uniform circular motion, the speed will vary. And if there is no tangential force, the motion will be uniform circular motion, it will be moving with a constant speed. In case of uniform circular motion, we know when there is no tangential force, only centripetal force is there, then we can write the time period as, that is the time for one revolution, 2 pi r times divided by the speed v. This formula we can apply when the motion is uniform circular motion, the time period for the circular motion. So whenever the particle moves in a circular path, there must be a centripetal force. We cannot compromise with the absence of the centripetal force. The tangential force may or may not be present. If it is present, the motion is non-uniform circular motion, and if it is not present, the tangential force is absent, only centripetal force is present, the motion is uniform circular motion. Correct? These are all fundamentals we covered in the chapter of circular motion. Now, whenever the particle is moving in circular path under the influence of gravitational force, it means the centripetal force is provided by the gravitational force, because we have seen centripetal force is not any new kind of force. There must be some agent to provide the centripetal force, and in this case it is the gravitational force which is providing the centripetal force. Now let's see what will be the outline, the skeleton or the roadmap for solving such problems. What you will do, you will take any one particle as the subject and make its FBD and find the net force on the particle acting towards the center of the circle. That will be the step 1. Step 2, whatever be the net force acting on the particle towards the center, that force will provide the centripetal force. So we will equate that force to centripetal force, that is equal to mv square by r, and then you can find the time and speed, time period and speed. You can find v, making v as the subject, then you can find the time period as t is equal to 2 pi r by v. Now in this article there will be different cases, like we will see identical particles in circular path under mutual gravitational force, we will see the binary star system, we will see the fixed particle and circulating particle, like one particle is fixed at the center and another particle is moving in a circle, and we will see the circular path in or around spherically symmetric systems. Okay, so these are the different cases which will be covered in this article. In today's lecture, we will see the application 1, that is the identical particles moving in circular path under mutual gravitational force. So this is the subject of today's lecture, and in the subsequent lecture we are going to explore the further applications 2, 3 and 4. Now let's see motion of particles under mutual gravitational force. Now suppose we have n identical particles. What is the meaning of identical particles? All have the same masses, okay, and they are moving in a circular path under the influence of mutual gravitational force. Now what it means, the mutual gravitational force, all the particles would be exerting gravitational force on each other. So these are the mutual gravitational force, like one is exerting a force on 2, and by Newton's third law 2 is exerting a gravitational force on 1. So under these forces each particle will be moving in a circular path. Now there is one fundamental. Whenever we have n particles of equal masses, n identical particles, and if they are moving in a circular path, okay, they are moving in a circular path under mutual gravitational force, then each particle will be located at the vertices of inscribed regular polygon. This is very important point. Each particle will be located at the vertices of n-sided. For n particles, there will be n-sided regular inscribed polygon in the circle. Okay. So suppose we have, like, to illustrate, we have three identical particles and they are moving in a circular path, say under the influence of the mutual gravitational force. So each particle would be located at the vertices of an inscribed three-sided regular polygon, and a three-sided regular polygon is an equilateral triangle. So in case of the three particle system, each will be located at the three sides of a equilateral triangle which will be inscribed inside a circle. Okay. If we have four particles, they will be located at the vertices of a square. Okay. So for n particles, identical particles moving in circle under gravitational force, each will be located at the vertices of n-sided regular inscribed polygon in the circle, like this. So this is the fundamental. So we'll see the first illustration, motion of two particles under mutual gravitational force. So suppose we have two identical particles. We have two identical particles and they are moving in a circular path. So say this is the center C and this is M and this is M and this is radius R. So the two identical particles, when they are moving in a circular path under mutual gravitational force, the particles would be located diametrically opposite. Always they would be moving, their position will continuously be changing, but always they will be located at the ends of the diameter. Now what is the approach? You take any one particle and find the gravitational force acting on it. So I am taking this particle as the target subject. You can take either of the particle, the result will be unaffected. So I am taking this as the subject. So the gravitational force will be, by Newton's law of gravitation, G, product of the masses, that will make m square divided by the distance. So this distance between the particle will be 2r. So it is 2r whole square. So you will get G m square by 4r square. Let it be equation number 1. Now you can see this is the net force on this particle. Net means resultant, no other force is acting, and the net force is acting towards the center. So there is no tangential force, correct? There is no tangential force. So since the tangential force is absent, so motion is uniform circular motion, and the net force acting towards the center will provide the centripetal force. So Fg will be equal to mass of the particle v square by r. So you will get the equation Gm square divided by 4r square is mv square by r. Now one m will get cancelled away and one r will get cancelled away. So you'll get the speed of the particle as Gm by 4 times of r. Okay, this comes to be the speed of the particle which is moving in the circular path. Now since the motion is UCM, you can apply the formula for the time period, correct? As the time period would be the circumference length 2 pi r divided by the speed. So the time period will be 2 pi r Gm divided by 4r under root. So you can write T as 2 pi and get r inside the radical. So it will be r square and r is already there. So we will get 4r cube divided by Gm. So this is the time period of the particle. So this is the first illustration where we have seen the two particles moving in circular path under mutual gravitational force. See, there is no new scale or no new concept, simply it is the concept of gravitational force equation and the centripetal force. Now I guess when we talk about the three particles, you can do yourself. What I recommend you, you can pause the video here, work out this problem, take 5 or 10 minutes, then come back and see whether your approach is correct or not. So suppose we have three particles, correct? And they are moving in a circular path, three identical particles. So by the fundamental we studied today, the three particles will always be located at the vertices of an equilateral triangle, inscribed equilateral triangle, correct? So this is my particle 1, this is say particle 2, and this is your particle 3, and this is the center of the circle, and say the radius of the circle is capital R, and the side of the equilateral triangle is A, correct? So see, you can take all three will be continuously moving in the circle. Their position will continuously be changing, but at any given instant of time, all three will be located at the vertices of an equilateral triangle. This scenario will never change, correct? So if you take any one particle and if you find the gravitational force on it, so suppose I'm taking this particle as the subject, okay? Say I'm taking this particle as M1, this is M2, and this is M3. So this will be the force on 2 by 1, and this is the force on 2 by 3, and this is the force on 2 by 1. In fact, both forces will have the same magnitude by Newton's law of gravitation. F23 is equal to F21 will be g m square divided by a square, correct? Now what will be the net force? So we got the case for two vectors of equal magnitude, and we know when there are two vectors of equal magnitude, if this is vector A and A both are having the same magnitude, the resultant will be at theta by 2, which is what? 2a cos theta by 2. So you can apply this end formula in this case. So the resultant force will be acting towards the center of the circle, correct? Because you see this line, the line joining the vertex and the center would be making 30 degree with this line, and this whole angle will be 60 degree, and both the forces are having the same magnitude, so you can apply this fundamental. So your net force on particle 2 will act along this line, that is towards the center, and this force will have the magnitude twice of the common magnitude, which you can write F23 or F21. So I can write F21 into cos of total angle 60 degree by 2. So we'll get 2 times of gm square by a square cos of 30 degree. So we'll get 2 gm square by a square, and cos 30 is root 3 by 2. So 2 will get cancelled away, and you will get what? The net force on second particle is root 3 gm square by a square, correct? So this is coming to be the net force on the second particle. Now since the net force is acting towards the center, so again you can say there is no tangential force if you are making the tangential axis like this. So there is no tangential force, the net tangential force is 0. So the motion will be UCM, uniform circular motion, and the centripetal force, which is F2, will provide the centripetal force is provided by the gravitational force. So you can equate the gravitational force with mv square by r. So you'll get 3 gm square by a square is mv square by r. One m will get cancelled away. So you'll get v square as root 3 gm r divided by a square. Now there is one more mathematical skill. You have to relate r and a, because it depends in which parameter you want to get the answer. Now if this is an equilateral triangle, correct, and this is center and this is r, this angle is 30 and this is a by 2. So if we take the projection of r, this will be r cos 30. So r cos 30 will be a by 2. So r root 3 by 2 will be a by 2. So we'll get r root 3 will be a. This is the relation between the radius and the side of the triangle. So suppose if you want to get the answer in terms of the radius, so in place of a, put r root 3. So we'll get v square as root 3 gmr divided by r root 3 square. So we'll get root 3 gmr by r square into 3. So we'll get gm by root 3r. So this came to be v square. So the speed will come to be gm by root 3 times of r under root. This is the speed of the particle, correct? Now if you have to find the time period, the time period will be 2 pi r by v. So you'll get 2 pi r multiplied by gm by root 3 r, and what you can do, you can bring r inside the radical, so you'll get root 3 r cube by gm. Okay, so this is the time period for the three particles moving in the circular path under mutual gravitational force. So we have done the special cases for two particle system, we have done the special case for three particle system. You can also, in a similar manner, you can do this case for four particle system. They will be located at the vertices of a square. You can find the net force on any one particle that will be acted towards the center, and equate that net force with mv square by r, and you will get the speed and the time period. So that is the first lecture for this article, the motion of the particle in circular path under mutual gravitational force. In the second lecture, we will see subsequent applications of this topic. Okay.